Okay, welcome to Module 4 of our Power BI course. Remember in Module 1, we said that Power BI has three main pillars: Power Query, modeling, and reporting. So we're through with Power Query. There's a lot more that you can explore, but we're through the fundamentals and the most used options in Power Query. So we are moving on to modeling. And if you look at the screen, I am on the model view. Okay, I'm on the model view, as you can see. And we have three tables. Remember, we have our three tables: the superstore table or fact table, we have the customer table, and we have the products table. So before we continue, we are going to create one more table, which is going to be our date table. And the best way to create this table is to use the calendar auto function, which is going to create a new table, picking the oldest date from your data set and the youngest date. So you create a calendar that begins from the oldest date from your data set to the earliest date. And we did our date table. We'll call it dim date since it's a dimension table, just to separate it from the fact table, which is our superstore. So we're on the model view and we are going to come up to new table. Okay, we click on new table, and that is the formula we're going to write on the formula bar. So it's dim date. And then we're going to use the calendar function, calendar auto. Okay, bracket, open bracket, close, and then enter. So when that happens, you see that we have a new table here called the date table. Okay, so let me bring it closer. So we have the customer table. We have and we can reduce it. We have the superstore table. Superstore, yes. Then we have the products table. Okay. Then we have the dates table. So dim date, right? Okay. So normally our superstores table should be in the middle, and the dimension tables should be outside, forming our star schema. Okay. So we have something like that. All right. So we're coming to connect the tables, okay? All right, so the tables, we have our four tables here and they are not yet connected. So we're going to connect each dimension table to the fact table. That's what we call star schema. Each dimension table to the fact table. So we're beginning with the customer table and we're going to identify the customer ID. And you click from the customer table, the dim customer, you click customer ID and you connect it to customer ID on the superstore table. And what happens? This dialog box opens, as you can see, and it says we're creating a one-to-many relationship, and you save it. Okay, so that is that. You can see that we have one here, we have the arrow pointing to the superstore table, and we have an asterisk here. So it's a one-to-many, telling us that one customer can have many transactions in the superstore, right? Now we're going to connect the products table too. So we have the products table. The products ID should also be on the superstore table. So we scroll to look for the products ID. Okay, so we click the products ID on the products table and take it to the products ID on the superstore table, and it's still one-to-many, which is the best. You one-to-many. You avoid using many-to-many relationships in Power BI. That is why when we're creating our products table, we ensure that we remove all duplicates, right? Since we have to do it manually. Now we have to connect the dates. So we can connect the other date. We can use the other date to connect. So we can take the dates here to the other date here, and it is a one-to-many as well. Why is first of all, why is the products to superstore a one-to-many? Because you can have one product that was ordered, one product ID, for example, furniture could have been ordered several times. So you have that one particular code being ordered in the superstore, and the date, of course, you can have one date on which many transactions took place. So you can call this superstore the transaction. So the date, this is our star schema. So you see that it looks like a star, right? All right, so we are good there. We'll come back later here and we can add other columns like the year column, the month, and all of that. All right, so that's very, very important for us to note when we are doing modeling. All right. So data modeling is one of the most important skills in Power BI because it determines how your reports behave, how fast they run, and whether your calculations return the right results. When you connect the tables like this, you can actually filter one from the other. You can filter the customer, the number of orders for the customer, the number of transactions for the products. You can filter, you can do cross filtering. All right, so it improves accuracy of calculations. Without a clear model, DAX will not work smoothly, like return wrong totals, and filters will not work properly because they will not be able to see what you're looking for if the tables are not connected and you want to get one thing using using one thing in the other table, and you want to be able to get it because there's no relationship, there's no route that you can take to get it. So time intelligence functions will break because, of course, they don't know what they're referring to. So if customer and orders tables are not linked, as I've just explained, for example, if the customers and the orders table are not linked, total sales by customer will return incorrect or duplicate values. It makes reports, so data modeling makes report faster. A proper model reduces data duplication, allows Power BI to compress data better, improves query folding. We saw query folding in module 3, right? When we talk about parameterization, and speeds up visuals and DAX measures. So this is very important. So people always skip this and then they rush to reporting. So every step is important in Power BI. Power BI is optimized for star schema, please. When you follow it, the reports are much faster. So Power BI was built for star schema, not snowflake schema, okay? So it allows powerful filtering. Relationships enable filtering from dimensions to fact table. Like we have 3-dimension tables here and one fact table. Accurate drill down and slices. Consistent behavior across all visuals. So you can select California, for example, in a slicer, and automatically you can filter for orders, for profit, for customers, for products. That's how dynamic modeling is in Power BI. So what is a star schema anyway? A star schema, as I've explained before, is when you have one fact table, which is the big table here, our superstore table, as you can see. And then you have dimension tables, okay? Multiple dimension tables. So a simple, clean, and very structured relationship. And each dimension table, Snowflake schema has dimensions broken into sub-dimensions. Like these dimension tables can be broken into sub-dimension tables. For example, you can have a customer table, and the customer table is linked to a city, and the city is linked to state, and state is linked to country. So you can have, it goes deeper. That's Snowflake. So this becomes a chain of tables, okay, like a snowflake blowing out, like move from one chain to the other. So this becomes a chain of tables, and it is not recommended in Power BI because it is complex, it slows performance, and filtering becomes confusing. All right. So we have seen how to create the relationships, and we now have our 4 tables, 3-dimension tables, and our one fact table. That is awesome. So in a star schema, we should have one relationship with tables. You can still have two, but only one will be active. All right, because you can ask that why don't we also connect the shipping date to the dates column? Like here, if you click this, the dim date, if you click the relationship between the dim date and the superstore, you see that it's order date, but also have ship date, right? So if I scroll down to ship date, you can still connect this date from the dim table to the ship date. But look at what, let me connect that. You click, you drag to ship date. Now look at what Power BI will say. It says one to many, cross-filtering single. Make this relationship active. No, we'll not check it here. See, it's blur. See, I checked it and what did they say? There are ambiguous parts between superstore and dim date. Superstore, dim date, and superstore. because we have two active relationships. We already had a relationship between the dim date and the order date. So we'll make this one inactive, all right? And we take save. And you'll see something. You see that you have a broken line, right? So whenever you see a broken line, it means that the relationship is inactive. So if you ever need to use that to use ship dates for to filter something with a date, the dim date table, you can come and make this relationship active. Okay. So you come now and make the first one inactive, and then you make this one active, right? That's it. So you can right click, take properties, and then you make it active. But that will be later, right? Okay. So I've talked about linking tables using one-to-many or many-to-one and not many-to-many. And there's a term for that which is called cardinality. And maybe you've heard about that before. So cardinality is when you have one-to-many, many-to-one, and many-to-many relationships. Okay. So the most common is the one-to-many, which you have seen here. All of these ones that we have are one-to-many, as we did it earlier. So that's the most common, and it allows one customer, for example, to have many sales. Like you have from customer to superstore. One customer can have purchased many sales here. Over the superstore here is actually our sales, like you see in most reports, is our sales table or the fact table, transaction table, anyhow you want to call it. And then we have many to one. It is the same thing as one to many. It just depends on where you began the relationship. If I had rather clicked from the customer ID in the superstore and drag to the dimension, that will be a many to one, right? It's just the opposite of one to many. It depends on which table you took the relationship from. So that's not a big deal. But the worst one is the many-to-many relationship, which happens when both tables have duplicates. That's why I remember when we were creating our customer table, since we did it from Superstore, we had to remove duplicates. If those duplicates were not removed, then we're going to have many-to-many relationship, and it is very, very bad in Power BI because it will give us wrong totals, it is ambiguous, and it will slow our reporting. So the perfect one is to use the one-to-many or the many-to-one relationship. All right. So just to reiterate our relationships, let me just right click on one of them and take properties so that we look at it again. You'll see that cross filtering here, we have what? Single, which is the recommended. You don't use both in cross filtering. I think you will have heard about cross filtering. Maybe in Power BI exams, you've seen the word cross filtering. So when you create a relationship in Power BI, you can either choose the single or both, but the both will filter both ways. Like you should only use it in special cases. For example, when two-dimension tables need to filter each other through the fact table, when building a complex financial model, or when building a logical bridge table, which are complex things that you may not need for a start when you are working with Power BI. So they're not even useful for star schemas, okay? And so you should not use it when you have a star schema like in this our case here. So always choose single to cross filter so that you can always filter one table using the other one. All right. So you can make the relationship to filter, like you can select a customer filter and then it is going to filter the sales table. But you cannot select a sales and it will filter the customer. That's what we are saying here. All right, so that's important. And like I was talking, let's close this. Like I was saying about making this relationship active, this one. So when you want to use this relationship, you are either going to come here and make the other one inactive, and then you make it active. Or the best way to do is to use it in a measure. All right. So you can have a calculate measure, and then you use the keyword use relationship. That's a keyword in Power BI. If you use the use relationship and you reference the dimension table, this dim dates table, and then you reference the fact table and you take shipping date, it is going to use this relationship. I don't know if you get it. So you are going to see that. All right. Let us talk about creating calculated columns versus measures. I think in the Power Query stage, we saw conditional columns, and custom columns, right? So I think we are going to move over to report view this time around. If you need anything to do in the model view, we're going to come back there. We also have our table view, which for now it has the dates table. If I click the dim customer on the right, you see it shows our customer table. If I click the products table, it shows our products table. If I click the superstore, it will show the superstore table. And then we also have the DAX query view, which will help you. It's just like for those who use SQL, you think you're used to this. You can write the DAX here, the DAX that we have written so far. You can see them here, like top end and stuff like that. Then you can also have the TMDL, right? So what is TMDL view? Just to give you, let's say, some introduction to that, so that for those who have Power BI, the latest version, you have the TMDL, which actually stands for Tabular Model Definition Language. So it is a text-based language, much more of SQL, something similar to SQL, which you can use to define, to view, to edit, and to manage Power BI semantic models. That's your data set, right? So when you hear the word semantic model, one thing that is a very big word. It actually is referring to your data set. All right, so those are just keywords on Power BI. So tabular model definition language can actually help you to define tables, columns, measures, relationships, manage DAX measures in a structured way, track model changes using version control and stuff like that. So we're not going to explore that for now. We'll have a separate video for that. So for now, let us just have to write on, and we're on the report view for now. All right, so calculated columns are actually very important, okay? So it is computed row by row, just like we saw conditional columns and custom columns in the Power Query editor. So the calculated column is different from a measure. We're going to see all of that. So the calculated table actually computes their data row by row during data refresh and is stored in the model, okay? So when should you use a calculated column? Use calculated columns when the value needs to be filtered independently in visuals, must participate in a relationship, and is needed as a slicer or category field, is a row level attribute. We'll see row level attributes later on. So let us say that you want to get profit, right? You have to get profit. And I think we already had profit from the Power Query. Let's look at the table view. We don't have profit. Then we can create a calculated column for profit. We already have profit, okay. So we did profit. I think we used, I click on profit. Okay, so it was when we were doing data modeling, data transformation, and we had to do add columns, new columns, and we had to compute like that. So those are calculated. No, these ones are custom columns, which are similar to calculated columns. All right. So let's get back to the report view. So if I come to customer table, I expand it, you will see that we have our profit already here. All right, so it's like it's a column, right? So that's fine. So let us calculate another one. Order to ship lead time. All right, so the columns will calculate the order to ship lead time. So for how long does it take to um, process an order until it is shipped? Okay, that's very important. So we are going to see that. So we are using the Superstore fact table. So we right click, okay, on it, take note, and we take new column. That's where we have calculated column. And then our formula bar opens. And on our formula bar, we can say that we want to calculate lead time. Lead time, okay? Lead time. And once we get it in days, we don't want to get it in weeks. So lead time in days. Okay, let me just maybe put days in braces. Power BI things that I just say lead time. So how do you calculate that? Is the difference not so? So it's the difference between the ship and the other date. So it's date diff. That's a function that you're going to use. Date diff, and then you reference the other date. table. So if I start typing other date, you see that it already pops up. So this is very dynamic. That's what we call intelligence in the coding in the modern technological terms. So we have the order date and we have this, no, 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 we have the ship date. So I just start typing ship date and it pops up. And what happens? I want the difference between these two and I want my answer in day. So when I put a comma, all of this pops up. I choose day and I close my braces and I hit enter. All right. Cannot convert value of standard class to type class. I'm going to go back to query and check the data types for our ship dates and our order dates, if they actually date. All right, so we are on the report view. We are going to click on, so we're going to click on the home, then we take transform data, and then we get back to Power Query. Let me share that screen. Get back to Power Query and we are going to check order date. So this is the order date. We click on it and we are on the home tab. We're going to check the data source. So the data type you can see here is text. As you can see even here, it's text. So let's just come out from the formula. Then we are on it's date here, as you can see, but up here you see that it's text, right? So we're going to write on the order date and we kind of have integer. So we come to the home tab, come to transform, and we just click on detect data type. And it changes to date, as you can see. So we click on ship. Of course, that is that. Let's just click detect data type is date, right? So we're going to close and apply. So we'll come to home, take close and apply. And then we come back here and let me share the new screen. So we come back here and we click on enter. So we still have the same issue. Cannot convert standard class of type text to type date. Let's just write it again. So date diff. So we're going to take the order date, the difference between the order date and the ship date. Then put our answer in this. All right, so write it again, and then we see that we have a calculated column, as you can see. This is it on the right. If you look at its own symbol, it's different. So that's calculated column, right? So sometimes you have to check your data types when you're working. All right, so that is it for calculated columns. We have seen the advantages. All right, so now let's look at measures. So what is a measure? A measure is calculated on the fly, depending on filters in the report. So measures are dynamic. And when do you use measures? Use measures when calculating aggregations like sum, average. In this case, we cannot use a measure because we are not agreeing any aggregation. We just want to look at the difference, right? So, but if you want to calculate some averages, count, use time intelligence, like compare the period between uh, this time and last time and the same time last year, you have to use measures to do that, all right? And if you want to do KPI, right, to get total sales, when we talk about KPI here, that the key performance indicators, like the key things that you're interested in the data set. Like in this case, we're interested in total sales a lot, the total revenue that comes in, we're interested. So those are our KPIs. We want to get some of those things that you can always use, maybe in visuals. You can use measures to create them. And measures don't have to be done row by row as in calculated columns and in custom columns or conditional columns, okay? So that they store a value at the runtime. So we're going to just create some measures. Let's just say we want to create a measure on total sales, total profit, uh, profit margin. I'm interested in that profit margin a lot. All right, so let us just calculate total sales. Do we even have it here? I think we don't have right? We have just sales, but we don't have total sales. This here is a column. So if we want to create a measure, we still come to the customer table, we right click, we take new measure, and then the formula bar will open, and then we have to rename it total sales, and then all right, total sales, and then we have to write our formula now. So what's the formula for total sales? It's very easy, right? It's a sum of what the sales. So you write sum, and then you bring in the sales. You close your brackets or your braces, and then you hit the enter key, and you will see that you have a new measure called total sales, and this is its own. If you look on the right where my cursor is, this is its own symbol. It's like a calculator or something. All right, so that's very important. We're going to use it in visuals. Okay, let's also get our total profit, because we have just the column for profit. We don't have total profit, and we need that to put it in a card. Also, when we're building our visuals. So let us get total profit. So you remove the word measure, and you write total profit. It's also the sum of what? Profit. So I'll just start typing profit, and since the column names are in memory, they will pop up. I click on it, close my braces, and hit the enter key, and you will see it. It's in alphabetical order. So we have total profit here. Now, what I'm very interested in is profit margin. What's the formula for profit margin? You have to take the sum of the profit, and then you divide it by the sum of the sales. That's profit margin, right? So it's like total profit, because profit is actually revenue minus income. Also, no, profit is revenue minus cost, right? Revenue minus cost will give you profit. So you have to take that profit and then you divide it by the total revenue or total sales. That will give you the profit margin. All right. So what we do is we still come, so since we're using the fact table, we still come on it, right click, new measure. This is very important because we'll also put this on a card when we are, or on a gauge visual when we are building our visual. So we're going to have a profit margin. We are going to divide. And what are we going to divide? We're going to divide the total profit. We already have it as a measure. So you just take total profit. When you see, yeah, when you already use the divide function, you don't need to put a bar, just put a comma. So we divide total profit by the total sales, or the sum of total sales, right? Sum of sales. But we already have total sales, right? So you just need to divide by total sales. No need talking about sum of sales again. You just divide it by sales. So if I start writing, I should have total sales pop up. And then if you want to make it in a percentage, it's okay, but we can leave it like this. So close the braces, hit the enter key, and save. So profit margin, that's it. So we're going to see all of this when we're building our visuals. So that's important. So we're already doing some DAX already. Okay, so we're moving ahead of module 4. We're already doing some DAX already. All right, so Is that we've seen fact table, dimension tables. We've seen um, cardinality also, like one-to-one relationship, one-to-many. So let us round up the module with data granularity. I think you've heard about this word also. So what is data granularity? So it explains how detailed your data should be and how to structure it properly before loading it into your model. These two concepts heavily affect DAX, okay? They also affect relationships and the report and also affect report performance. So we have data granularity and we have normalization concepts. So what is granularity? It is the lowest level of detail in a fact table. So our fact table here, let's just go to the model view. Our fact table here is a superstore or the series table if you want. So the lowest level of detail is what we call granularity. So in our superstore, each row is equal to one product in one order. Let's open the table view. Let me show you. This is the table view. Are we in the superstore? All right. So each row is an order. So that's the lowest level of detail. Like you cannot go beyond this, right? So each row here is an order. Each row is an order, and each row talks about a particular product that was ordered by this person. Is that's the lowest level of detail. So that's what we call granule. Even though the word from the word granules, tiny substances, right? Tiny particle. So that's the lowest level of detail, all right? And so order ID like 101 may have three products, and in that way, it will produce three rows in the superstore table. Yes, you can have an order ID that has three products, and in that way, you will not write the three products on the same row when you're creating your data. And also, each of those will be, for example, if you filter this row ID, I will not be speaking in space. If you filter the row, no, not row ID. If you filter the order ID, right? Look at the order ID. We should have even looked at it in the Power Query. So you see what I'm talking about. Let's just say we want to filter and leave just the CA 2014 on a 100006. Okay. So you see that we have one product for that ID. Now let us leave that so you understand that the ID has to be unique. All right. Let us leave that and come over to product. Product table. So let's go to the products table. Let me show you. So we have products in the customer in the superstore table. The products that was ordered. We have it there. So we have the category of the product. We have the subcategory. So if let's say you have binders, right? Binders is a product, no, so subcategory of product. But under binders, you have the very detailed type, the specific type of binder that was bought. So is that each type of binder that has its own row, which is the lowest granularity. That's granularity, the lowest level. Okay. So let us select all of it back. Because when you hear this word granularity, it might look a bit scary. So why does it matter to have your data to the finest detail like this? Why does it really matter? It matters because that calculation becomes simple because it depends on it. That calculation goes row by row, and so you are using columns and those columns have rows. So it makes your DAX, but DAX depends on it. Aggregations depend on it. Date relationship will depend on it. Joining dimensions depend on it. So if you have good granularity, like in the superstore where we have each sub product having its own role, it is good because somebody could just come here and since you have subcategory, you just write at, which means only here you're going to have four different, even this Noel 327, you have Noel 317, Noel 307. So somebody will just come and put this under one row, right? That is Noel, in well, in well. Not so. But now you have to separate it into the finest detail. Each one should have a role. So a customer can come in and buys 10 products and you will not put those products on one row. You have to put them on 10 different rows. All right. So that's what we're trying to say here. So it all depends on how you design the model during data capturing. Very important. So that you don't have to spend time separating all of that when you're here on Power BI. All right, so we move on. So fact the fact table, we have one row per product per order per day. That's what I've been explaining all along. Now let's just look at an example of bad granularity. If we aggregate the data before loading, only total sales per order, or you lose product level analysis. If order date appears at the customer level instead of the order level. So let me explain this since you have the manual there with you. Let me explain. So, like I said, you write just the customer name and the products that they have bought, you put comma, you write those products. If you do that, that's bad granularity. You're supposed to write the customer name, the customer ID. You take each product, each order should have its row. If you rather put many rows, because it's one customer, Mr. Sam, who came on board, and you just have his ID, his name, and then you write the things and put comma, you're going to have issues. That's going to be very bad granularity, which will disturb, okay? So this one is not a DAX, it's just of what? Data preparation and the way you design your data capture and your data sheets and all of that. Okay, so what is normalization? So it's organizing data to remove repetition. In Power BI, it applies mostly to dimension tables, okay, not the fact table. So like when we were in module 1, we had to create the customer table and the products table and we remove duplicates. So that is normalization in business intelligence. So no repeated text values. So if you have state, you can repeat 100 times in the fact table. But if you go to the customer table, or the customer should appear just once in the customer table, although that customer can appear 100 times in the superstore. And it's very, very easy. Why is it that a customer will appear just once in the customer table? Because the customer table captures the customer ID and the customer name and where they come from, the state and all of that. But now that same customer can order, like we say, it's a one-to-many relationship, right? It's very easy. That same customer can order many products And so you have one customer who have many orders, who has given many orders. And so you have to find out that in the fact table, you have one customer appearing many times, but in the customer table, it should appear just once. That's normalization. So you are talking mostly about our dimension tables here because when you talk about star schema, it might look very easy, but when you get into run into trouble, that's when you're going to perfectly understand what we are teaching here. So when you are designing your dimension tables, please make sure it is row by row, one customer. For customer table, in the products table, you have one row, one product. So let's go to table view and see dimension product. All right, so dimension product. So you have one row per product. Okay, so that's the product ID. They don't have to repeat. One product ID at a time. You don't have this ID appearing twice. Okay, it can only appear once in the product table, but it can appear twice in the fact table or more than twice. All right. So you should only include attribute related to the entity. For example, in the products table, we should not see customer name in the product table. This is a product table. Do we have customer name here? Let's check. If you have it here, it's wrong. The customer name should be in the customer table. You should have the product name. All right. And then you should not have the products in the customer table as well. It should be found in the products table. So in the customer table, you should not be having sales, profit, quantity. Is that true? Let's take the customer table. Customer table, we don't want to see products, quantity, all of that. That should be found in the fact table where the recording actually took place. All right, so we've covered a lot in modeling and we've done some DAX already. And this will be the end of module 4. In module 5, we'll write more DAX. We'll write more DAX like the sum, average, count, distinct count, and in module 6, we'll see advanced DAX like sum X, DAX, count X, and all of that. Then in module 7, that's when we're going to actually start doing visualization, which I know is what you have been waiting for. But that's actually one of the last steps, and it is as good as all of this preparation. All right, so see you in the next module.